in do loop cycles and turning cycles for turning operations. Okay, so one type is remaining. So that is we are not used means inch unit for solving any problem. So for this, this is a simple example in which half we will consider this OEM we will consider as a half or a FANUC control, half or FANUC control system or OEM machine is there, and we will use instead of we will use instead of this uh, metric unit, we will use inch unit. So because the dimensions given in that diagram, you can see it is in the inches. Okay, so let's begin. What will be the difference we will see. So in this programming for a half system, the programming name, as we are using the percentage for symbol. So in this, it is start with O. Suppose O1136 is a programming name. Okay. Then N10 or N5, N05, N05. So first you have to define, that is same G90 is for absolute coordinate system. Then G, so in this G21 will be for metric unit, and G20 is for inch unit. So G20 that is for inch unit. Then G20 is the inch unit. Then G94, that is in feet. I will use G95 instead. That is speed is in mm per revolution. And then G54, that is the offset of the workpiece. Okay, so end of the block. Next, we have to define the tool. So this is a boring operation. So N10, P0, M06, C01. Okay, that is this tool. Okay, so I will use your speed here 2000 RPM, and speed will be 0.01. Now inch per revolution. So this will consider the dimension is in inch. So 0.01 inch per revolution. Okay. So that means 10 mm per revolution. Okay. So next N15. N15. Now in this we are going to use a cycle for this. Turning 71. G71 is a turning cycle here, and separate codes are there for this. What means you can see this P5 now P20. So what is this P20 mean? Your cycle starts from which line? So this is 20 is for the series. Okay, and then when it will end. So don't write Q, make some space for this, because we don't know how much lines it requires. So this will be your N20. Okay, so you have to write P20. So your cycle starts from this series number or N20. Okay, so that means this P20. Then Q, write it afterward. What is the end of your cycle? You have to write that series. Then Yeah, I have tell you that U, W, and Z is UVW, sorry, UVW is used for X, Y, and Z. So here only two X's are there, so this V will be not there. So in our system, they have given you U, U minus 0.1, 0.1 inch, okay, 0.1 inch. Then W is 0.0.01. So it means that this is the center and it is just 0.01 in upward position from the center. So if we consider this as a 0, then it is 0.01 in upward direction, that is x direction and negative direction, and W means that it is just away from the 0.01 in the z direction. Okay, so you can write down 0.01 or 0.05. So 0.5. Okay, so this is randomly we can take. Okay, then another D is there. So D 0.08. So what is this D? That is the cutter compensation. So you have to write here also for the cutter compensation. You have to write G41. Okay, so because it is in right, G71 is the cycle, no, G41. So D is that this is the compensation in inch. So 0.08 will be the offset for the right. If we change the diametrically, this will be the compensation value. Okay, so end of the block. Okay, so we have seen now today the new values or new wording in the block, that is P for the starting of your cycle, Q for the ending of the cycle, U is for X, W is for Z, and D is for the cutter compensation, radius compensation. Okay, that is the value of that. Okay, next G00, the next block. Just a minute. Wait a minute because the sale is acting. I have to just a minute. Okay. G 00 G00 X 4.5 X 4.5 is set. Okay. Uh, so my cutter now my cutter is uh, now my cutter is at the diametrically 4.5 inches. So now the cutter will move in this downward direction. Okay, so 4.5. Okay, next G00 end of the block. Okay, then N25 N25 G01. Now the cutting will start. G01. Now we have to define the X. So you can see this. The diameter is 3 inch. So diameter is 3 inch. So specify that value. Specify at value X3 X3 inch, and the radius uh, so is point X3, and the radius is point uh, point 25. Here it is the radius. So previously this hole is done. You have to make this radius operation and then another boring operation. So boring operation is, you know that previously a hole is made, and in that if a radius is there or increases the hole size, as you use this boring operation. Okay, so on this line G01 is the cutting will be done, and the will be radius will be set as a R.25. Okay, so that is this radius. Okay, so in this line is missing, that is the spindle start line is missing, so you have to, I will write down here N, so you have to write down N11 M03, that is clockwise direction, and M09, sorry, 8 for the coolant on. Okay, so this will include in this cycle. This line will not include in this cycle. Okay, because we have specified that our cycle is starting from P20. Okay, so next N30. Now the cutting will be done. Now the cutting will be done with the radius. Okay, so 0.5 is the radius. Okay, so first it has cut this portion. Sorry, it is of R25 will be cut over here, and then this radius will be cut of 0.5 inch radius is there. So second, at this point, at this block, it will cut this corner radius. Okay. Now next, next is the for this R5, you have to use Z minus or in this instead of this G01 you have to use, it is in which direction when it is cut, this direction will be it is in anti-clockwise direction, so G03 should be there. This is a printing mistake in the notes. So J03 is there for that cutting, and for this cutting is clockwise direction. It will act as clockwise direction, so you have to use G02 for cutting, and what is the length? It is to 1.75. So Z minus 1.75. Minus 1.75, and radius is R is 0.5. This radius 0.5. End of the block. Then next M35 X 1.5. Okay, so now the cutter will move in upward direction for the next cut. Okay, so X 1.5, and you have to use the G code also. So it is the you can see over here this radius. It is of point. Yes, will be given you R 0.125 inch. So this is the radius first. Then second radius is over here. Then third radius is over here. Okay. So for that, as it moves from in the clockwise direction, so it is moving from this to this. It will move in upward direction, and then it will move in anti-clockwise direction. The cutter will move in anti-clockwise direction. So G03 for this radius, G03, X 1.5, X is 1.5. Okay, from where you get this? From here, 1.5. Okay, so diameter is given, that is 1.5. You have taken this X 1.5. Okay, then the next one R, you have to specify the radius 0.125 inch. Okay, so this, now you have completed this radius. Okay, now next N40. In this you have to go in straight direction. So here is another radius again of 0.125. Okay, so for that again this will be in anti-clockwise direction. No, it is in clockwise direction. So G0 Z minus minus 2.25 2.5. Okay, 2.25 is distance. You can see over here 2.25 is the length distance and radius is 0.125. Radius is 0.125. Next, N45. Now this radius has been done. Now the last radius is remaining. Now for the last radius, yes, and this of this radius is remaining. Okay, so for this x again G03 x 0.75. You can see over here diameter is 1.75 and radius is same 0.125. Okay, 0.125. And then last is z minus 3. Z minus 3 here too. That is the entire this length is given. I think it is given. Just a minute. Where is it given? Diameter. Okay, it just passes through this position. So you can take -3 or -2, anything you can take to pass from this point to here. This point. Just create a path. N50. Take G01. G01 Z. I will take Z minus 3. Okay. So now last F 0.73. Okay, N55 X 0.73 or 75. You can take 75 is given 0.75. So no need to add this line because we have completed this 0.75 over here. So that will be the end of your cycle. So N55 G70 to cancel the cycle, and P starting of the cycle is you have to write down starting of cycle is started at 20 and we have ended at 50. We have ended at 50. Okay, so yeah, also you have to write that at 250. Okay, that is a series of the block. That is a series of the block. Okay, the end of the block. Now just stop the coolant and all. Okay, so N60, so M05 and M05, and you can bring first this compensation is also should be cancelled. So G40 and G00 write down that values again. U minus 0.01 and W 0.005. Okay, cancel. And now N65 M05 stop the spindle and stop the coolant. M09 and last will be N70 M30. So program stop and it gets reset. Okay, so in this way boring operation can be asked for the examination. So rarely asked for the examination. Just I have shown you one type, that is block line, how it is used. So for this purpose, and the boring operation we have not covered. So that's why I'm showing you this type of problem. Okay, by using another unit, that is inch unit we have used, and another type of OEM, that is Haas CNC program example. This is a Haas programming. So next, uh, from this, so for examination, this will not ask. This is just for your information and type to be covered. But sometimes these problems can be asked for examination, and that is over this pocket milling. Okay, so pocket milling by using the subroutine program. So this is a subroutine example. Subroutine example. So in subroutine, the difference between the regular one and the subroutine programming is that the regular we have doing this, we are doing only this outline of the profile. Okay, that's covering it. Okay, so if this pocketing has to be performed, has to be executed in the machining, in the CNC machining, then it will be really difficult to again go for the second cut, then again go to third cut, fourth cut, in this way as per the step 4. And the number of lines are not possible manually to execute this. It is a simple program, but if die manufacturing is there, and then at that time this programming will not be possible. So for that purpose, this subroutine programming things are used. So difference between this part programming and subroutine programming is that it uses two programs. That is, one is your main program, and another one is a sub program that is repeated again and again. Okay, so after just you have to give the step word. Just you have to give the step word so that it will repeat. It will start machining from this inner end. Okay, then after that we have given a step word. Then it will cover this. Okay, and it will cover this, and in this way it completes the this toolpath. Okay, so that is the use of a subroutine program. So so basically it have two programs in this. Okay, main program and a sub program. So let's see with this simple example for pocket of a square block. Okay, so pocket milling operation. So in this they have given you, again this is in the inch unit. So five inches are there, and this radius is of they have given you zero point 0.5. zero point 0.5 is the radius, forming radius of this square. Okay, and the tool they have given you radius given is 0.5, sorry, 0.5 inch. Okay, and the tool P01 they have given is of 0.5 inch in diameter 10 mil cutter, in mil cut. Okay, so in this way they have asked you to develop the manual part programming by subroutine. Okay, so main program and sub program. So in this we are considering this as your Siemens OEM. So main program, right? Main program, in that percentage. So 100, suppose. So this is the name of the main program, and sub program will be the second series, means 1002. Okay. So now again the lines are the same for the starting. That is, you have to mention the You have to mention N. Okay, you can mention the series, or you can can mention the series of this N series, or otherwise you can if the editing is not there, and editing is not required, then no need to write the N series. Okay, but most preferably you have to use the N series. So N05, N5, G90, G for absolute coordinate system. Then G, now you have to use G70, that is for the inch unit. Okay, inch unit, G70. G feed rate, I will use feed rate in per minute. So inch per minute. So G94, G94, G54, that is versus offset. Okay, so these are the same lines. N10, N10 for N10, I have to mention the tool. So M06, T01, T01. Okay, so this is the tool you have mentioned, that is of 0.5 inch diameter in mill cutter is there. Okay, at this point, and you have to specify the speed. Speed I will give 2000 rpm, 2000 rpm, and feed rate is suppose 50 f50, f50 inch. So 50, so yeah, that is more, so I will use 10 instead of the 10 inch per minute. Okay, so this lines will be the same as that of the simple part programming. Okay, so I have to start the spindle N3, M03, that is in clockwise direction, and start the coolant dot M08. Okay, end of the block. Next, in this you have to give the cutter height compensation. Okay, so for the height compensation, you have to use the code or the in positive and negative. Suppose if they have specifically told you that the height of the cutter of the previous workpiece zero they have one, and is a smaller in size, then you have to use the positive. If it is larger in size or height in length, then you have to use negative, and you have to write the value of that. Okay, so how to write it? So N20, G43. Okay, so I am considering that it is a positive. We have to add, suppose the length of the cutter for the workpiece 0. Okay, workpiece suppose it is of length, suppose this is of length 49 for the first cutter for the workpiece 0 they have used, and our now this end mill cutter is of 50. So uh, is of 50. Hmm? This length is 50. Then I have to use G44. Okay, if this is 50 and my now cutter is length is 49, then I have to add one into it. Okay, so at that time I will use G43. Okay, G43 when the previous cutter is means shorter in length. If the this cutter we are going to use is larger in length and compared to the previous one, then you have to use G44 and the value of the height compensation. Okay, so this, right? So G43 H is the value you have to specify, H1. So it is in inch, so it is difference between the first cutter, the workpiece 0 cutter previously used, and this cutter, which is made for the offsetting of the tool for the workpiece 0, that tool, and this tool difference is length difference is 1 inch, 1 inch. Okay, you have to write that, and just hit z axis 0.1 in. Okay, then g01 and 25 g01. Suppose we are now at this point. Okay, so this is the starting point. Then you have to move to 1, then 2, then radius, then this, and radius, this. Okay, you have to complete this in this. This is the tool path. Okay, then again step over you have to view. Again it will go inside this. Okay, then again it goes inside this. Okay, so in this way, just now. So in this way, you have to generate the operation. Okay, so this is the tool path. Okay, so what is the use of this subroutine program? You can see over here. Okay, so so point one is the distance from this starting position. They have given you this. X is 0 from this is the origin point. X is 0 and y is 1.5. Y is 1.5. Okay, they have given you in this. That is the starting position value. So x will be there at the center. So this is the origin where x is 0 and 0. Okay, and at this point, this distance covered is 1.5. Is 1.5. Okay, so from this you have to start the machining. Okay, so before that, first as you define this height compensation, and then you have to move the tool. Okay, from z point 1 g01 g01, and the depth given is depth of the square pocket is of 0.5. 0.5 is the depth. 0.5 inch is the depth. So you have to first drill the tool inside this first. Okay, starting point. So G01 is 01 where this 0.5 depth, it will cover the depth first. Okay, now it will move from this position, starting position, and to this one, to this one point. Okay, so for that N30. Okay, now we have to specify the programming line. So difference is now, so you have to specify that the name P. Now the P is used for the subprogram name. So I will use 1002. That is my subprogram name. So after completion of this block, it will directly move to the subprogram. It will complete that. Okay, so with a depth of how much? Minus zero point 0.5 depth, with the depth of minus zero point 0.5. Okay, minus zero point 0.5. Okay, and what is the step over? Now the Q is used for step over in this. Q is used for step over. 0.25 is my step over. Step over means when it completes one circle, one this profile, then again it will move inside this. Okay, so this is the step over. So this distance is 0.25. Then again it will move inside 0.25. Then again it move inside the 0.25. So in this way, the step it moves inside is the step over. Okay, so 0.25 is the step, and the radius it is going to cover is r 0.01. Okay, and uh, in this I, J, K you have to use. So point 3 radius. So this radius given is a is of point 0.3 radius, point 0.3 inch radius. Sorry, point 0.5 inch radius is given. So you have to use here uh, j equal to point 0.5, that is in y-axis, and then again k should be in the k should be your I, J, and K. So K is the Z axis, so you have to keep the same as that this 0.01. Okay, 0.01, and you have to mention the cutter radius compensation. So as it is pocketing, I will rub this first. Okay. As it is pocketing this, so it is a G41 is used. G41 is used from the left, cutter combination from the left. If it is, we are going, suppose block is there and over this it is machining, right? Then you have to use G42. And when we are going to pocket this, then you have to use G41, that is cutter composition of the radius towards left. Okay. So, and we have to mention the difference also, D01. So this is the compensation with the radius compensation with the tool number 1. Sorry, compensation of diameter with the 1 inch. Okay, 1 inch diameter compensation is given. Okay, then N35. Now the P is not used for this series. It is for the subprogram name, and Q is used for the step 1. Okay. Then after completion of this one by one the completion. So this when it gets at this 3-point radius, at 2-point radius, at this 4-point radius, at this 5-point radius, okay, then your J means Y value of radius will be 0.5, and the Z should be in the 0.01 approach at that time. Okay, so this should be known, and I equal to 0. I should be 0 in this. Okay, so N35 next G G40. So this line will be repeated till the end of this. It comes back to the origin point. Okay. So on completion of the pocket, it will be repeated. How much it will be repeated, that is given in the sub program. Okay. So G40 is the cutter compensation cancel. Okay. And G01 after cancellation, X 0 and Y 1.5. That is the starting point. That is the starting point given again. Okay, and then we have to write N40 G00 Z1. So I'm moving the cutter upward. Okay, and then you can use G28 also, but before you have to use this, then N45 G28, that is the homing position, and then you use N50 you have to use, and you have to stop the spindle M05, you have to stop the coolant M09, and you have to reset it M30. Okay, so N55 M30. Okay, so this will be stop. Okay, then you have to use the percentage symbol again. Okay, so this completes your main program. This is your main program. Okay, now the sub program, you have to specify the coordinates. In the sub program, you have to specify the coordinates. So write down sub program starting with which name we are going to use, P 1002. So write down that 1002 in the box. Okay. So at this point it will refer this subprogram. At this point it will refer the subprogram. Okay. So for this G01, G01, okay, Y 2.5, Y 2.5. So what is this 2.5? You can see this from this one point it is moving towards 2, 1 to 2. When it moves from 1 to 2, it is y-axis is 2.5. Okay. So up to this point, up to this 2 number point, and it will take this consideration, that is depth is 0.5 minus 0.5, radius is 0.1, j in y direction, it will cover this radius with 0.5, and in z 0.01. Okay. So this will cover all this. Okay. End of the block. Now again, for the next line, so this is, I will write for your reference, this is from 1 to 2, when cutter moves from 1 to 2, from this position 1 to 2. Okay. Next 2 to 3, 2 to 3, you have to write down directly x minus 2.5. So we are using G90. So for that, don't use minus. In this also there is wrong. Okay. So you have to use from this position. This is okay. I will use G91 here. G91 will be much easier. G91, so that it will this all subprogram is in incremental system. That will be much easier to understand. Okay. So G91. So from this point 2 to 3, what is this? That is 5. Okay. We have 5 x in y direction. We are moving. So just a minute. From 1 to 2, it is moved in x direction. Sorry, this should be x. This should be x. This should be x. Okay. And then from this y, from 2 to 3, it should be 5. It should be 5. Okay. It should be 5. Then again from 3 to 4, x direction, again in the positive direction. Okay. So x will be 5. Okay. X will be 5. Then after that, again it will move in upward direction. Then 4 to 5. 4 to 5. I will write this properly. Okay. This is y5. So in this we are moving from 2 to 3 in y direction. Okay. Now in x direction, x5. So 3 to 4. 3 to 4. Then from 4 to 5. 4 to 5, only y will change. Y will change. That is minus 5. Okay. Because downward direction it will be positive. Sorry, this should be negative, as it is moving the point at the incremental point from 2 to 3. This will become 0. So no direction of y will be negative. From this will become again its origin point. Right side of the x will be positive. And then from moving from 4 to 5, it is in upward direction. So this will be positive. This will be positive. Y 5. Okay. Y5. Then again this will become at this point, this will become the origin. Now to move from this to this, okay, 5 to 6 minus 2.5 minus 2.5 minus 2.5, and this is also minus 2.5 first because it is moving it towards left side. Okay, so it is minus 2.5, and next again after this we have to bring the tool to this starting position again. So for that only you have to change the y, that is in negative direction. So y to 1.5, y yes, y y minus 1.5. Okay, and then you have to just lift this, so z1 z1. Okay, so and you have to write m99 m99. So this is from 5 to 6, it will move from 5 to 6, this will move from 6 to starting point. This will lift, this will lift. Okay, okay, so in this way the step over it will cover. So first it will cut this. Okay, in this way it will first cut this part, okay, by one cut. Then again step over it takes of 0.5 it will take step over. Again it will change its uh, by this position, it will change the position by zero point 0.5. Okay, zero point 0.5 it will reduce it the ratio, and it will complete the program. And m99 is to return to main program. So this is compulsory we have to use, and you have to end with the percentage. So again it will go back to the main program. Again it will repeat that. Again it will come here. Again it will machine the pocket. Okay, so this will repeat it until you get the entire pocket. Okay, this will repeat by step over of 0.25, step over of 0.25. So in this way the subroutine program works. Okay, so any questions? Because this will be asked rarely in the examination. So just to practice this, I will this program, and the program in the next lecture I will ask you. So only these two types will be asked. Only the dimension will be changed, or the metric units they will ask you in the metric units. Instead of 5 they will ask you 50 or 60. Only dimension will be changed, but this method of this will be remain same. Okay, and this will be asked in the examination, but you have to practice this. Okay, so any questions regarding today's session you can ask me. Okay, I will download your attendance first. So we are taking another problem over this. Okay, so that will be more clear to you, and I will again repeat this in this program. I will again repeat for you just for the revision purpose. Okay, so what is the use of subroutine program? Okay, so just like cycle programming, it use the sub program for repetition. That's the in the simple word we can say. Okay, okay, so we will stop today over here, and we'll meet for the practical session on batch B at 2 p.m. Okay, I'm ending the session. Thank you for listening.